Hello and welcome to this second video on completing the square with quadratic equations. In this video, we're going to continue what we did the first time, and we're going to start with this example, which we're going to use completing the square in order to change a quadratic equation to the vertex form. And in case you've forgotten vertex form, it's y equals a times x minus h squared plus k, where h comma k is the vertex of the parabola, and your a value does your vertical stretch and compress, and reflection, just like in the a in your function transformation. Okay, so let's go about doing this one now. So the first thing I'm going to do is get it equal to 0. I'm going to move that 25 over to the other side. And I'm going to factor out a greatest common factor so that my leading coefficient is 1. Just as if I'm going to complete all the way to solve for the roots, which I'm actually not going to be completing it all that way. All right, so I'm going to add b over 2 squared. So that means I'm going to add 9 here. But I have to keep in mind, not only am I adding 9, I have a 2 outside the parentheses, so I'm really adding 18. So I add 18 to the other side. So I have 2 times x minus 3 squared equals negative 7, or 2 times x minus 3 squared plus 7 equals 0. So my equation of this parabola is right there. Now I want you to keep in mind, you can check this by taking it and graphing it on Desmos to make sure that the two equations are equal. That will help you to see if you have any errors or if you've made an error along the way. So if I go to Desmos, I'm going to graph the original parabola. And then I'm going to zoom out a little bit so you can see it. Graph my completed square form. And I can see they're the same graph. All that happens is I change color here. We can also see that the point 3, 7, the h and the k here are the vertex showing up right there. So we can see that there. So we haven't made a mistake. Okay, now let's continue. Our parabola transformations, as I mentioned a minute ago, you can transform that vertex. And I mentioned that the a value in your vertex form here is the same as the a value here. So I'm going to start with that. It's our horizontal, stretch, compress, and reflect. All right, stretch and compress is going to be that the scale factor is the absolute value of A or the absolute value of little a, okay? And reflect is if A is less than 0, which is the same as capital A.
Can Aiden Williams
Okay,
please report
H is the x coordinate of the vertex. Sorry about that. Okay, so it's the x coordinate of the vertex, but it also gives us the horizontal shift. k is the y coordinate of the vertex, and that gives us the vertical shift. Don't forget, when you're doing h, it changes sign. So if it's minus h, you go to the right. If it's plus h, you go to the left because it's an inverse operation. But for k, it's the same as the sign. If it's plus k, you go right. If it's minus k, you go left. And we should be able to graph some parabolas using these transformations from the basic parent function. So let's look at the basic parent function of any parabola, which is y equals x squared. So if I just graph a couple of points, okay, if I square -2, I get 4. If I square -1, I get 1. 0 squared is 0. 1 squared, 2 squared. This is our basic parent function. From the vertex, we go right 1, up 1 to get the first point, and right 2, up 2 squared to get the second point. And of course, those are reflected over the axis of symmetry. Well, if we picture using that to graph a transformation, like maybe this first one here, okay, x plus 2 squared minus 3, well, that one's going to have a vertex of -2, -3, based on our HK rule, -2, -3. And because the A number is 1, that means it's going to have the same over 1, up 1, over 2, up 4, over 3, up 9, and the same width as a traditional parent function parabola. So over 1, up 1, over 2, up 1, 2, 3, 4. I can create a graph of that without a lot of effort and without having to make a table and plug in numbers or any of that stuff. Let's practice doing this again. All right, this one has a -1, so it's going to be reflected, and the vertex is 5, 1. All right, so at 5, 1 is my vertex, and it's the same width, so it's going to be the same width as this one, over 1, up 1, over 2, up 4, but it's going to be reflected because of this negative. So I'm going to go over 1, down 1, over 2, down 4 from the vertex, and reflect those to the other side. So when the parabolas aren't terribly complicated, we can graph them without a lot of effort. All right, this last one. We have an A value of 2, which means everything's being stretched vertically by a factor of 2 from the x-axis. And our vertex is 3, -6. Okay, 3, -6 is right here. Okay, so what I'm going to do, instead of going over 1, up 1, I'm stretching it by 2. So I'm going to go over 1 and stretch it twice as far. So instead of going up 1, I go up 2. And then usually I would go over 2, up 1, 2, 3, 4, but I'm going to stretch that by a factor of 2. So I'm going to go over 2, and then I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8 is twice as far as 2. And reflect them. And you can see this parabola is narrower than the other ones we have graphed. And when I do these, I would make it simple. You would have, simple things. I wouldn't give you like a stretch factor of, 7.2 or something like that. It'll be like 2, 1/2, 3, that kind of thing. So we can use transformations to graph them without making a table. It is also possible, as we discussed, you can use completing the square to go from standard form to vertex form. Well, you can also go backwards just by foiling it out or following your order of operations on this. So here we have one in vertex form. I'm going to change it to standard form. And I'm going to do x minus 5 times x minus 5 to square that out. So that gives me x squared minus 10x plus 25. Then, following my order of operations, after exponents, I have to multiply. 2x squared minus 20x plus 50. And finally, combine any like terms, adding. And again, you could check on Desmos to make sure you haven't made a mistake. Just was with anything that we have graphed here, you could check and make sure you have not made into a mistake. All right. A sailboard manufacturer. Okay, we're doing an application problem that uses this now. Uses a computer-driven automated machine to manufacture the masts for its sailboats. Here's a function. It's programmed into the computer to make one such mast. Okay, so this is the mast for the sailboat board. Write the quadratic function in vertex form, graph it on Desmos, and sketch it below. Well, we're going to do it a different way. If writing it in vertex form, you can complete the square, there's another way you can get the vertex that I don't want you to forget. Negative b over 2a gives us the x coordinate of vertex. I would not recommend doing this one by completing the square because it would be a little too nuts to do that. So negative b over 2 times a. Now I'm just going to use my calculator to change that to decimal form. So negative 3/5 or 0.6 divided by the fraction 2 over 250, which is 1 over 125. When I do that, it gives me the value of negative 75. All right, that's not bad. Okay, now to get the y coordinate of the vertex, I'm going to take my x value and plug it in. 1 over 250 times negative 75 squared plus 3/5 of negative 75. I get negative 22.5. So that means our vertex form, the a value is the same as capital A, 1 over 250 times x. X coordinate of the vertex is minus 75, so we're going to put plus 75. And the y coordinate is negative 22.5. You can graph this on Desmos to see the sketch of the graph at negative 75, negative 22.5, and get a picture of the graph. Now, if they want to play with the mast with a greater or smaller curve, what they would do is they would adjust that A number. So that is the end of this lesson on completing the square. Join us for the next lesson where we will be doing graphing and using the quadratic formula. Oh, but before that, we will continue on with completing the square.